Okay, good morning, class. So today we're looking at the November 2022 paper 2. So at this point we got up until question 4.1. So we are told that in the diagram, M, which is 3 and negative 5, is the center of circle having Pn as a diameter. So if Pn is your diameter, Kl is a tangent, so this has to be 90 degrees here. Okay, and then N is 2 and negative 2. The first question says calculate the coordinates of P. And since P is the one of the endpoints, and of course this is the midpoint, I can use the midpoint formula in the reverse. Okay, with the converse thereof. And we got P to be negative 1 and negative 8. Okay, so the next question. Question 4.2, we are told determine the equation of the circle in that form. So if you got this circle, so it's 4.2.1, it will be in the form of x minus a squared plus y minus b squared is equal to r squared. Where a and b is the center of the circle, so it's going to be x minus 3 squared plus y plus 5 squared is equal to r squared. Now one of two things I can do here. I can either work out the distance of mn, mp, pn, which is diameter, and divide by 2, or I can substitute in, which is 7 and negative 2. Or I could have substituted p, which is negative 1 and negative 8. Remembering that's a x and a y. So I got 7 minus 3 squared plus minus 2 plus 5 squared is equal to r squared. 2 squared is 4. 3 squared is 9. It's going to give you r squared to be 13. I can take the square root if you want. But the questions asked to get it in standard form of the circle. They didn't ask you to calculate r. So it's x minus 3 squared plus y plus 5 squared is equal to 13. Okay. Huh? 25. So this is going to be 2 squared. That's going to give you 3 squared. How did I get 13? So that is 4 and 9. Which is 25. No, it's 30. Where did I go wrong? Oh, 7 minus 4. 7 minus 3 is 4. And 4 squared, 16. It's giving the answer of 25. My mistake there should be 25. I don't make that mistake. Okay, so that is 25. So that's, okay. Sorry about that. So yes, it's 25. Then the question in 4.2.2 says KL. So KL, we know it's the tangent. So that's of course perpendicular to the diameter. So the gradient of the diameter is going to be negative 2 minus minus 5, going with the m and n, and then 7 minus 3. Okay, that gives us an answer of 3 over 4. So the gradient of the tangent times the gradient of the radius or diameter is minus 1. So the gradient of the tangent, of course, is going to be negative 4 over 3. So y is equal to negative 4 over 3x plus c. To calculate c, I can only use a point that's lying on this graph. In this case, it's n. So you'll substitute n, which is 7 and negative 2. Remember then, that's the x and the y. So negative 2 is equal to negative 4 over 3 times 7 plus c. So c works out to be, you got negative 2 plus 4 over 3 times 7, which is 22 over 3. So therefore the equation is y is equal to negative 4 over 3x plus 22 over 3. Okay? Right. So y is equal to negative 4 over 3x plus 22 over 3. Okay. Any other confusion there? You can give it to somebody else you want to eat from. You sure? Okay. Okay, so with that, what was the equation of the circle, just in case we need it? So it'll be x minus 3 squared plus y plus 5 squared is equal to 25. Yeah? So let's see what's the next question have in store for us. I shouldn't have dropped it so low. So always bring it back so we can have the diagram in focus. Okay. In 4.3, we are now told that for which values of k will y is equal to negative 4 over 3x plus k be a secant to the circle. Now, a secant to a circle is a line that's going through the circle, that's cutting the circle at 2 points. Okay. So, if you do the comparison with y is equal to negative 4 over 3x plus k and the tangent, you'll notice that it has the same gradient. Which means to say that this line that they're talking about is parallel to that line. Okay. So currently, as it's going through any tangent, there is a secant. Or a secant will be a secant all the way up until P. And beyond P, it won't be a tangent or a secant. Okay, you guys understand? So it will be a secant as long as it's less than this tangent or more than that tangent. But that k, that variable k, is actually a y-intercept. Okay, as you can see here, so the y-intercept for the upper part, the upper limit is going to be 22 over 3. Okay, so anything less than 22 over 3, but more than your y value at this point here. Okay, so how do we calculate that point? We say we got y is equal to negative 4 over 3x plus c. Since it's going through P, we'll substitute P, which is negative 1 and negative 8. That's an x and a y. So negative 8 is equal to negative 4 over 3 times negative 1 plus c. So c works out to be, we got negative 8 plus 4 over 3 times negative 1. Negative 28 over 3. Okay, which is the lower limit. So as long as k is greater than negative 28 over 3 or less than 22 over 3, it will be a secant. Okay? More than that would be a greater than 22 over 3. It will be just a line passing the circle. And less than 22, a negative 28 over 3 will be also a line passing or missing the circle. Okay. 4.4. Okay, so I'm going to take this off here. Everything in green is not needed now. Okay. Now in question 4.4, which is purple, in question 4.4.1, in 4.4 we are told point A, which is T and B. So A and B are not shown in the diagram. From point A, let's call this A for now. A could have been there. From point A, which is T and T, another tangent is drawn to the circle to touch the circle with center M, which is the circle here, at B. So say that's another tangent there. Okay. If I draw a here, then the tangent would have been there. Or if I could have drawn a tangent there. Or if A is there, I would have drawn a tangent there or wherever. You guys understand? As long as a tangent to the circle. Okay, why do I draw it? So that it can make sense to. Okay. Now we are told that 4.1.1 show that the length of AB is given by. So we must calculate the length of AB. And what we do is, to calculate length, we need distance formula. We can use the distance formula. However, at this point, we don't have the coordinates of B. Not so. So, what we need to do is, we can construct a triangle here. We construct a triangle, the tangent is perpendicular to the radius. So what comes to mind? Pythagoras. Can you see that, people? So I can calculate AM's distance. So AM is going to be the square root of x2 minus x1 squared. So it's t minus 3 squared plus y1 minus y2 squared, which is t plus 5 squared. Okay, that is AM. We know that MB is going to be the square root of 25, which is 5. It's the radius. You don't have to write radius. So what I'm going to do is, I know that's 90 degrees. Do I need to state it? No, I'm not busy with Euclidean geometry. Okay. So what I do is, I know it's 90 degrees, so I'm going to apply Pythagoras. So AB squared is equal to the hypotenuse squared, which is AM squared minus MB squared. Again, you don't need to write that. So it's going to be the square root of t minus 3 squared plus t plus 5 squared is equal minus 5 squared. So that gives us.
Mr. Bodin.
Yes, ma'am.
Looking for in lambda Yasi, she perhaps with you?
No, miss.
Okay, thank you.
Okay, so it's square both sides. So t minus 3 all squared is going to give you t squared plus, minus 60 plus 9 plus t squared plus 10t.
My apologies for the interruption. In lambda Yasi, can you please?
Plus 25.
In lambda Yasi.
Minus 25. That cancels. So it's 2t squared plus 4t plus 9. So that is for AB squared. Can you see that, people? Therefore, AB is equal to the square root thereof, which is 2t squared plus 4t plus 9. Okay. So they have just proven that AB can be written as that. Okay. Yes? Any questions? Right? Then in 4.2.2, okay, question 4.2.2, we'll just take us off. Determine the minimum length of AB. So there's two ways of doing that, okay? It's either I can complete the square. So let's complete the square. So it's going to be 2 as a common factor. It's going to be t squared plus 2t plus 9 over 2. So that's going to now give us 2 into t squared plus 2t plus a number minus the same number plus 9 over 2. Okay, the number in this case is going to be 2 times half, which is 1, and 1 squared is 1, and that is your perfect square number. Okay, so that's going to give us the square root of 2 into t plus 1 squared. This was in bracket, of course, plus 7 over 2. Okay, multiply the 2 out. So I got 2 into 2 plus 1 squared plus 7. So if you look at this here, this is under the root is a quadratic function, a smiling parabola. And of course it has a minimum value. It has a minimum value of 7 occurring at an x value of negative 1. Okay, so we're going to write the 1 there. Negative 1 and 7. Okay. So because it's under the root, it's simply going to be the square root of 7. Okay. Right. That is one way of doing it. Otherwise, what I could have done was, I know that the minimum value will occur at the minimum value under the square root. Okay, provided that of course the number can't be negative. But if we take the fact that it's a quadratic, and so we can work out the minimum value here. So we work out the derivative of under delta, derivative with respect to delta or under the root, whatever. It's going to give you 4t plus 4. Say that equal to 0, I can drop that. So t is equal to negative 1. So you substitute negative 1 back into there. So it will be the square root of 2 into negative 1 squared plus 4 times negative 1 plus 9. It's going to give you the square root of 9 minus 2 plus 2 minus 4, which is the square root of 7 anyway. I think that's a bit easier than completing the squaring. Okay. Let's go to the next question. Question 5. So here in 5.1, we are given that the square root of 13 sine x plus 3, where x is an element of 90 to 270. Okay, so we're taking that over the equal sign, becomes the square root of 13 sine x is equal to negative 3. So sine x is equal to negative 3 over the square root of 13. So this tells us that sine is negative. Okay? So in which quadrant is sine negative? Which quadrant is sine negative? Quadrant 3 and 4. Now this is that is greater than 90, but less than 270. You all agree with that? So it's in quadrant 1 and. So in which quadrant do we draw it in? The third quadrant. You all agree with that? So let's draw. So there's your angle x. Sine is opposite over hypotenuse. Remember, hypotenuse or radius is never negative, so the negative belongs to the 3. We also know that it has to be negative because that belongs to the x-axis, the negative part of your y-axis. For work that x-axis out, I must apply Pythagoras. So the square root of 13 squared is equal to negative 3 all squared plus your adjacent side squared. Okay. So that's going to give you 13 minus 9 is equal to your adjacent side squared. That's going to give you 4. So your adjacent side is going to give you plus minus 2. Which one of the two is it? Must be the negative one. Because that's a negative part of your x-axis. Therefore, if you look at the sine of 360 plus x, which quadrant is that in? Quadrant 1. Sine is positive, so it's simply sine x. So sine x is simply negative 3 over square root of 30. Okay. Huh?
They don't have the last one. They just have sine.
Say again?
They only have sine.
So they didn't work this out yet. Not yet. Without using calculated dividend. Let me see the answer. Okay. Because you see the reason why they don't have this part of the calculation is because that is not needed yet. Not so, because in the first question they don't need the adjacent side, so they didn't do that in the calculation. So they just wrote sine x. Is that what you said? I think that's a mistake from this side. So let's look at the next question. Let's pull this down. So the next question says tan of x. So what does tan stand for? Tan is opposite over adjacent. So it's negative 3 over negative 2, which is 3 over 2. You all agree with that? Is there any confusion? No. And then cos of 180 plus x, which quadrant is that in? All stations to Claremont. 180 plus x is in quadrant 3, so it's negative cos x, which is negative cos adjacent over hypotenuse. So it has to be 2 over the root of 13. Okay. You all agree with that? Another mistake then. Aren't we making a mistake? To get over, that becomes negative, no? Divide by negative root 13, so sign is negative. Those two quadrants. 90 to 270. You all agree it must be in the third quadrant, no? Okay, let's carry on. Determine the value of the following expression without the use of a calculator. So again, reduction formula comes into play. All stations to Claremont. So 90 plus, it takes you into the second quadrant. Is cos positive or negative? Negative, although it changes to sine of theta over theta minus 180. Now, if you're looking at sine of theta minus 180, that is your theta angle minus 180 takes you into that quadrant there, which then tells you that sine is negative sine theta. Now, say you don't think in terms of negative angles. Let's say you get a bit confused when it comes to negative angles. What we do is we add 360, which then becomes sine of 180 plus theta. 180 plus theta takes you to the third quadrant anyway. Sine is negative, so it's negative sine theta. Okay, so either or, you'll get the same answer. Okay. Times, plus. Now, negative theta is in this quadrant here, so it's going to be negative 3 sine theta. Again, if you that kind of girl who doesn't want to work with the negative angle, again we add 360. Remember, we add or subtract 360, I don't change the value of anything. So that is simply 360 minus theta takes you into the fourth quadrant. Sine is negative sine theta. Okay, and times the positive, of course, is negative. Which now gives us negative sine theta over negative 4 sine theta. Sine theta's cancel, leaves you with 1 over 4. Okay. General solution, our favorite. In terms of general solution of the following equation. So firstly, it's already factorized, so it's in the zero factor rule we're going to use here. So cos x plus 2 sine x is equal to 0. So cos x is equal to negative 2 sine x. So sine over cos is? Sine over cos is 10. So I'm going to divide both sides by cos x. So then I'm going to have negative 2 tan x is equal to 1. Divided by negative 2. So tan x is equal to negative half. Okay. So what we do now? We work out our reference angle. Reference x is equal to arctan of 2. Remember, we have a positive outlook on life. So we use our positive angle. Okay. So arctan of a half gives you 26,57. 26,57 degrees. So right, so what question comes to mind? In which quadrant is tan? In which quadrant is tan? Positive? No, yeah. Which quadrant is tan? Negative. So in which quadrant is tan negative? Second and fourth. But when it comes to the tan, I only represent it in one. Not so. So we go with the second quadrant. So quadrant 2 is simply x is equal to 180 minus 26,57 plus k times 180. Okay, the reason why I just go with one quadrant is because the other quadrant gives you a repeated solution. Unless you go 360 minus 26,57, and if you have to run the the solutions between a given interval, you'll see it will overlap. Okay, and we spoke about that already when we did the tangential solution in grade 11. Okay, so that gives us 153, 153 comma 43 plus k times 180. Okay. Otherwise, you could have just represented it in quadrant 4, and you could have said x is equal to negative 26,57 plus k times 180. It's the same thing. Okay. On the other side, the other factor, we're going to say that 3 sine 2x is equal to 1, or 2 sine x minus 1 is equal to 0. Take it over the equal sign, becomes positive 1 divided by 3. So sine 2x is equal to a third. So I work out my reference angle. Again, you do not divide this reference angle by 2 until you've taken it to the quadrants. So arc sine of a third gives us 19,47. So it's 19,47 degrees. So which question comes to mind? Which quadrant is? Which quadrant is sine positive? In 1 and 2. Sine is positive in 1 and 2. So let's go with quadrant 1. How do we get into quadrant 1? Is the angle, the difference is 2x is equal to 19,47 plus k times 360. So I divide by 2, gives me 9,74, 9,74 plus k times 180. Oh, right? Quadrant 2, how do we get in quadrant 2? It's 180 minus 19,47 plus k times 360. So that simply gives us 180 minus 19,47 divided by 2. Gives you 80,265, so it's 80,27 plus k times 180. And don't forget to add, k is an element of integers. Okay. You see how you're wasting your time there at the back? It's the second time you're not sleeping in my lesson. But now you're doing something other than maths. Come on, man. Yeah. Below 5.4, you're given the identity cos x plus y times cos x minus y is equal to 1 minus sine squared x minus sine squared y. Prove the identity. So of course the left hand side is more, will be easier to work with. Expansion is going to be easier than reduction here. So the left hand side of the equal sign, and I'm going to use the cos rule. So the cos alpha plus beta is going to be cos alpha cos beta minus sine alpha sine beta. Okay, so that's the first one. The second one, the same story. Let's move this over a bit. The cos x or cos alpha minus beta is going to be cos alpha cos beta plus sine alpha sine beta. So what you should note here is that we have a conjugate pair. Okay, so we can multiply the first and the last, which will result in difference of two squares. Okay, so that's going to become cos squared x cos squared y minus sine squared x sine squared y. Okay, so if you look at what we have sine squared x and sine squared y. So I'm going to keep that. Sine squared x, sine squared y. Okay. So what I'm going to do is I'm going to change cos squared x to 1 minus sine squared x. This is from the squared identity. And cos squared y can be written as 1 minus sine squared y. Minus sine squared x, sine squared y. Okay. So we multiply to get rid of the bracket. So it's 1 times 1 is 1. Minus 1 times sine squared y is sine squared y. 1 minus 1 times negative sine squared x is negative sine squared x. Plus sine squared x, sine squared y. Minus sine squared x, sine squared y. So what do we notice now? Is that these can cancel. Not so, which leaves you with 1 minus sine squared y minus sine squared x, which in turn is equal to the right hand side. Okay. Then in 5.4.2, we are told that hence, so hence means to say, I must use the previous calculation, determine the value of sine squared 1 minus sine squared 45 minus sine squared 15. But if we look at what we have, okay, look at what we have, okay, what we notice is on x's place. What is on x's place? 45. What is on y's place? 15. Can you see that? So you're going to work on the other side, of course. So it's going to be cos x is 45, so it's 45 plus y, which is 15, times cos of x, which is 45, minus 15. You see that? So in turn, it's going to give us cos 60 times cos 30. So that takes us to the special triangle here of 30, 60. So it's 1, 2, root 3. Cos of 60 is a half times cos of 30 is root 3 over 2. So it's root 3 over 4. Okay. A nice question there to link it. In 5.5.1, consider trigonometric expression. 16 sine x cos cube x minus 8 sine x cos x. Rewrite the expression as a single trigonometric ratio. So as you can see there, 8 sine x cos x is common. No? So it's going to be 8 sine x cos x is common factor. I'm then left with cos squared x minus sine squared x. No. Cos squared x minus 1. Yeah. And we know that sine squared x is equal to 1 minus cos squared x. So what is cos squared x minus 1? So it has to be negative sine squared x. Not so. Yes? 2. Right, so that's not going to work. So it should remind us of something else. Alright, so 2 that is from the compound angle. So cos 2 theta is going to be 2 cos squared theta minus 1. Is that correct? In this case, we have an x here. Okay? So that would be 8 sine x cos x times cos 2x. Okay? A single trigonometric ratio. Okay, so this part here should remind us of the sine double the double angle identity, which is sine 2x equals 2 sine x cos x. But we have an 8 so it's 4 times 2 sine x cos x. Okay, that's the identity I'm looking at, times cos of 2x. So it's going to be 4 sine 2x cos 2x. So hang on. This now can be written as 2 times 2 sine 2x times cos 2x. So into x's place, sorry, I've got the 2x now. Which means to say this is going to be 2 times 2x, which is 4x. So that's simply going to give us 2 sine 4x. Okay. Another good question there. I like it. The next question says, for which values of x, or value of x in the interval for x is an element of 0 to 90, will this have a minimum value? But what is this, people? This is actually equal to 2 sine 4x. If I should draw this graph from 0 to 90, the graph is going to do that. This is normally 360 divided by 4 in this case. It's going to give you 90. And that is normally 1, but because of that 2, it's going to give you 2 and minus 2. Okay. So they ask you with regards to the minimum value occurs here at this point. There's a minimum value of negative 2. Not so, but what is the question? For which value of x they want to know is the minimum occurring. So then this would be simply 45, that is 45 divided by 2, which is 22.5. And x is equal to 22.5 plus 45, which is going to give you 62.5. 67.5. No? Yeah, 67.5. Okay. Which is this point here, 67.5. Okay. Nice. Yes? Let's look at question 6. In the graph below, the graph of f of x equal to tan x, g of x equal to 2 sine x, 2 sine 2x are drawn for the interval negative 180 to 180. 60 and k and b are 2 points of intersection of f and g. People, these are 3 graphs. We know that they're going to be symmetrical. Okay? Above certain points there, with distance between 2 points and so on. So the question says, what is the period of g? So firstly, I need to write down my equations here. So we know that f of x is equal to tan x, and g of x is equal to 2 sine x, so 2 sine 2x. So g is the sine graph. The normal period on the sine graph speed is normally 360. But because of that 2, there's going to be 360 divided by 2, which is 180. You all agree with that? Then let's just calculate the value of k. So where's k? Yeah. Okay. So as you can see, k is lying on both g of x and f of x. So I can say f of 60 is equal to tan of 60, which gives me an x value of, or k value of, sorry, a k value of tan 60 root 3. That if you that kind of girl like to write in decimal, no problem. If you a sine kind of girl, 2 sine 2 times 60 gives you root 3 in human. Okay, so any one of the two, because it's a point of intersection, should give you the same solution. People, the next question is the coordinates of b. So 6.3, the coordinates of b, so that's going to be root 3. As you can see from this point 90 to a, which is 60, it's 30 units. So that is also 30 in that direction. Can you see that, people? So 30 in that direction, of course, is going to give you negative 120. And if I put negative 120 into tan of x, I'm going to get root 3 anyway, which is also in line with that point, or that line y is equal to the square root of 3. That's the root of 3, and that is b. I'm going to put it on the diagram. It's going to erase all of the stuff now. Alright, next question. Next question says, write down the range of g of 2 g of x. So There's actually 6.2.2, 6.3. So what is the range of g of x? So if you look at g of x, g is the 2, so it's going to be 2 till minus 2. That is the range of g of x. Okay. So what effect does the 2 have in front of the g of x? It's going to enlarge the graph by 2. For those of you who can't see it, if g of x is 2 sine 2x, you multiply that, I'm going to get 4 sine 2x. As you can see, its minimum and maximum is going to be negative 4 to 4. Okay. But have you answered the question? To answer the question, the range of this graph is y is greater than or equal to negative 4, but less than or equal to 4. Again, what is the range? The range is all possible y value. Okay. Look at the next question. 6.4, we are now told that what did I need? Okay. Now, 6.4, for which values of x will g of x plus 5 minus f of x plus 5 be less than or equal to 0. So the first thing I do is put the box away. Yeah. So what I do is I say, okay, take that over the equal sign and drop the 5 for now. The shift of 5. And that means to say that we have g of x is less than or equal to f of x. So let's look at where that is the case from negative 90 to 0. That's all I'm looking for. Okay. So where is that the case from negative 90 to 0? Where is f on top? Where is g at the bottom? So this is the f of x graph. So as you can see here, f of x is at the bottom here. Not so. So it's less than. Not what I'm interested in. However, it's less than from that point in that direction. Okay. So if that was the question, the answer was simple. Okay. This should be 45, so that's going to be 30 in that direction, so it's going to be negative 60. Okay. Remember, that's also 30. Alright? So if that was the question, it would have been x is greater than or equal to negative 60, but less than and equal to 0. Right. But that isn't the question. There's a shift on the graph. So, how does this affect the graph? This is going to shift the graph 5 degrees to the left. So this becomes negative 65 and this becomes negative 5. Can you see that, people? Just remove 5 degrees to the left. Whoops, not that, but the whole, both graphs. So in other words, what they're looking for is x is greater than negative 65 and equal, but less than equal to negative 5. Okay. In 6.5, determine the value for p for which sine of x times cos of x is equal to p. I have exactly 2 real roots in the interval from negative 180 to 180. Okay? Just take this off here. People, what are roots? What are roots? X-intercepts. That's all. The roots are x-intercepts. If we look at this here, okay, from negative 180 to 180, let's use purple. From negative 180 to 180. Okay, so firstly, what is this? We know that sine x cos x, that reminds me of the compound angle. the double angle, okay, of sine. So it needs a 2, so it's 2 sine x cos x. If I multiply one side by 2, I will multiply the other side also by 2. So this reminds me now of 2, sine 2x is equal to 2p. If I now compare to what I have here, I only have that part. So what am I shorting? A 2 in front of 2 sine 2x. So if I put a 2 in front of this, and then 2 must go on that side as well, which is now going to give me g of x is equal to 4p. Okay. So now coming back to the question, it says determine the value of p for which sine 2x plus, so in other words, if g of x equal to 4, will have exactly 2 real roots in the interval. Okay, so currently, how many roots does g of x have? Currently, g of x has 1, 2, 3, 4, 5 roots. Not so. Roots are x-intercepts. There are 5 roots. Oops. Sorry about that. So more exciting questions to come. So currently we have 5 roots. Okay, let's just take this out. What's happening now? Sorry about this. So there are 5 roots, no? So what I do is I take that graph in particular, the geometric graph, and then I investigate. Sorry about that. If I take this graph and I move it there, how many roots will it have now? Is 1, 2, 3, 4. That's all. Sorry. So there's 4 roots there. What if I move it down? How many roots are there? 2 roots. And that's what they're asking for. Not so. Right. Let's move up. How many roots? 4, 4, 4. Here? 5. 4, 4, 4, 4. And then? 2 again. Can you see that, people? So in other words, it's got to do with the turning points. Not so? So it's in other words, where that occurs, this is actually where 4p is equal to, what's this value here? 2. Or 4p is equal to minus 2. Where am I getting that from? My maxima and my minima on G. So in other words, is where 4p is equal to plus minus 2 divided by 4. So p is plus minus a half. Okay. So that's that. Very, very good question. I like it. Right, question 7. So our 3D problem now. So we are told here that AB is a vertical flagpole that is root 5p meters long. AC and AD are two cables anchoring the flagpole. B, C, and D are the same horizontal plane, assuming that's the ground. Then we are told that BD is equal to 2P. Then we are told that ACD, the outer triangle there is going to be X, and ADC, which is also the other angle from the outer triangle, is going to give you 45 degrees. The question says determine the length of AD in terms of X. So AD in terms of X. AD. So it's this triangle here. And in terms of P, sorry, not X. P. So since it's a right angle triangle, I'm going to use Pythagoras. So AD squared is equal to the root of 5P all squared plus 2P squared. No reason needed there. So that's going to give you 5P squared plus 4P squared, which is 9p squared. The square root of that is going to give you 3p. Okay. 7.2. Before you guys go, I know you want to go as quick as you can. In 7.2, it says show that the length of CD, so this is outer limit there, in the outer triangle. CD is equal to 3p, so I must pick up this here. Sine x cos x over 2 root sine x. Okay, which is this here. So CD, as you can see here, we can calculate this angle. So CAD is equal to 180 minus x plus 45. Okay. This is 180 minus x plus 45. Okay. That is sum of triangles. Because we've got so many angles here, we're going to use the sine rule. So we say sine of 180 minus x plus 45 over CD is equal to, because you want to pick up 3p, we're going to go with an angle opposite, which is sine x over 3p. I'm going to cross multiply and reduce. So that would simply be 180 minus, next to second quadrant, sine is positive. So it's 3p sine x plus 45 is equal to CD sine x. I'm going to expand the sine compound angle in. It's going to be 3 sine x cos 45 plus sine 45 cos x equals CD sine x. So I divide by sine x both sides. Then take a calculator away. Right, so that will cancel. So therefore CD is equal to, that is 1 over root 2. That is 1 over, that one here is 1 over root 2. I'm going to take out 1 over root 2 as a common factor. Yes, there must be a p in it. So it's going to be 3p over root 2 into sine x plus cos x. And this is all over sine x. Since this is your denominator, it can go to the bottom. Which now will give us, therefore, CD is equal to 3p sine x plus cos x over root 2 sine x. Okay. And the last question. I'll ask you if it's further given that P is 10 and X is 110, calculated the area of triangle ABC. So what I'm going to do is I'm first going to calculate CD. So CD is going to give us 3 times 10 into sine 110 plus cos 110 over root 2 sine 110. So it's going to be 3 times 10 open bracket sine 110 plus cos 110. And this is over the root 2 sine 110. That gives us 13,49. Okay? 13,49. Now to calculate the area of this triangle, which triangle is this? ADC, of the triangle. So the area of triangle ADC is equal to, we're going to use that as the included angle, so it's going to be half 3p, and p is 10 times 30.49 sine of 45. That gives us half times 3 times 10 times 30.49 sine 45. That's 10, 1, sorry, 143, 143, 11 units squared. Okay. So what we have left is geometry. Okay. So sometime when I have a couple of minutes, I will record the geometry and I'll post it online. Okay. All the best with your mock exam. Good morning, class.